name is Bryson Wingate, and this is my Project 2 game, Reverse Runner. Now, Reverse Runner is a falling object survival game where the player must crash into the obstacles and stay alive instead of avoiding them. Now, of course, I'll demo the game, walk through my GED section by section, explain the code architecture, answer the required interview questions, and finish with a post-mortem reflection. Now, of course, this is the start screen, and as you can see, oh, hold on. As you can see, the player can start by pressing space. The instructions explain that the player moves with A and D or the arrow keys and must crash into the falling blocks to maintain momentum. Now you can see the green screen is the player and the red blocks fall from the top of the screen, and from moving left to right, I can move horizontally to intercept the blocks. Now, as you can see, when I hit a block, my momentum increases in this as shown by the bar. And momentum here is the survival resource. Now, as you can see, it can drain automatically over time, but if I move left and right, it will also drain faster, which means movement has a cost and must be used carefully. Now I'm gonna let the game run for another couple seconds, but as you can see, as the round continues, the block will fall faster and the momentum will drain faster, of course, as well, which would make the game much more difficult. And I'm gonna let the game end here. So I'm just gonna. And now, if momentum reaches zero, the game transitions over to the game over screen. Now for the GDD. Basically, my elevator pitch was that Reverse Runner is a falling object survival game where colliding with obstacles is necessary for survival. And the core player fantasy is the controlled risk taking, because instead of avoiding danger, the player has to actively seek it out to continue the game. Now, within the scope, what's included is 5-lane movement, falling obstacles, a momentum system, collision rewards, difficulty scaling, a survival timer, game over state, also a game over state. And what I deliberately excluded was stuff like character customization and power ups, and these were removed to keep the project focused on a single core mechanic. Now, the success criteria was that, like the last game, the players would quickly learn the genre subversion and intentionally sync collisions. Now, as for the major systems, we got the player system, the obstacle system, the collision system, the momentum system, the difficulty system, the UI system, and the UI system. And the most important relationship is the relationship between the collisions and the momentum. Now, instead of the usual collisions causing damage, we have collisions increasing our momentum in this game, and this architecture design directly supports the genre subversion that was assigned to me. Now, for the mechanics, obviously the game's primary mechanic is the collision momentum. The trigger is collision with a falling obstacle, and the effect is momentum gain. Now, some of the most important parameters are obstacle speed, momentum drain, movement drain, momentum reward, and difficulty scaling. And as far for edge cases, the most important one was momentum reaching zero, which would of course immediately end the game. Now, as far as target aesthetics, I chose challenge, discovery, and sensation because, well, for challenge, it basically comes from balancing movement cost against the momentum gain. Discovery comes from learning that the obstacles are beneficial rather than dangerous. And as for sensation, it basically comes from increasing speed and movement slowdown when the momentum is low. Now, for the positive feedback loop, you go from hit obstacle, gain momentum, survive longer, reach higher difficulty, then continuing seeking obstacles, while the negative player feedback loop is avoiding obstacles, then you lose momentum, but then you become slower, and then you feel the pressure, then you feel the need to seek the obstacles again. Now, the plan technical structure included the player object, the obstacle object, the collision detection, movement management, difficulty scaling, and canvas rendering. And the final implementation did stay close to this plan, of course. Now, as for the UI and flow, the game has three states. Of course, as you saw, start, playing, and game over. And the HUD, of course, contains the movement momentum bar and the survival timer and the current obstacle speed. And for the onboarding, the onboarding occurs through the start string instructions and immediate gameplay feedback. Now, of course, as I said, the features deliberately removed was stuff like power-ups, character scans, and even multiplayer. And of course, I removed these because these would increase development time without improving the core mechanics. And of course, I had like two major open questions. Basically, what would happen if the players would players understand that the collisions are beneficial automatically, and would the difficulty curve remain fair at high speeds? And these, of course, became the major testing goals for the during development. And of course, the project was made with HTML5. Now, of course, I make with at the top of the file are the core game state variables. Line 35 stores the game state. 37 through 46 define the lane positions, obstacle spawning, and difficulty values. 48 through 59 define the momentum system, including the drain rates and rewards. And 61 and 62 track our survival time. Now, for our update player function, our player speed is completely calculated from momentum. Higher momentum creates faster movement, and lower momentum creates slower movement. And movement, of course, as you saw, automatically drains momentum, and which creates a direct relationship between resource management and player control. Now, as for the updating, force missed it. Spawning our obstacles. Each obstacle is randomly assigned to one of the 5 invisible lanes, and of course it keeps spawn. There's only a limited amount that can spawn on the screen. Now for updating obstacle movement, of course obstacles have to move downward and are removed once they leave the screen. And for the difficulty system, difficulty, of course, like the last game, difficulty increased based on our survival time. And with more time, obstacle speed increases and the passive momentum drain increases. And the movement momentum drain also increases as well, which keeps the pressure increasing throughout the round. Now for momentum. Now this function automatically handles the momentum updates, and as I previously said, momentum continuously drains, and the display bar smoothly interpolates towards the actual momentum value. And of course, if the momentum reaches 0, the game transitions to the game over state. Now for the collisions. Now this is the most important function in the game, and this is where the genre convention is reversed, because instead of collisions causing damage, collisions increase momentum, and after momentum is restored, the obstacle is removed, basically. Now for the HUD, basically the function draw HUD draws the user interface, which displays the momentum, the time survived, the current obstacle speed, and also the current obstacle speed. And the momentum bar, of course, as you saw, changes colors based on the remaining momentum. Now, as you saw from line 291 to, I made the start screen and the game over screens, and together with the gameplays, they of course create the 3 game states described in the GDD. And of course, I have our draw game function, and this function basically coordinates all gameplay updates like player movement, timer updates, difficulty scaling, obstacle updates, collision checks, momentum updates, and of course rendering. And finally, the main loop. This is basically, of course, this is the master loop. It basically checks the current game state and renders the correct screen. And the loop continuously updates using the request animation frame. All right, now that that's over for the questions, the genre conversion subversion. So basically, the genre convention I subverted is the expectation that falling obstacles are dangerous and must be avoided. Basically, normal players would, of course, avoid falling objects, and but in Reverse Runner, players actively seek them out, and this changes the feeling from avoidance to controlled risk taking. Now, for the core feedback loop question, the player basically moves towards the falling block, and the movement also costs momentums, but collision restores the momentum so that the player can survive longer. And this player has to learn to intentionally seek collisions, which creates the game's core feedback loop. Now, for the MDA, of course, like I said, the target aesthetics was challenge, discovery, and sensation, and the momentum system creates challenge by forcing resource management as the round goes on. The genre subversion creates discovery that the players must learn that collisions are beneficial, and the increasing speed and movement slowdown create the sensation that creates sensation. And playtesting showed that players changing from avoiding obstacles to intentionally chasing them, which also supports the discovery aesthetic. And for the last question, our most fragile architecture component would be the update difficulty. Is basically because the most fragile part is basically the balance between the obstacle speed and the momentum drain. And small changes to these values would dramatically affect difficulty, and because obstacle speed, passive drain, and movement drain all interact with each other, balancing them, of course, required careful testing. Now, for postmortem reflection, what really went well was, of course, my choice of genre subversion, in that players could understand that the reversal and eventually could understand the reversal and begin chasing obstacles. Now, what went wrong was that the early versions did not make the movement meaningful enough and didn't make it difficult enough. Now, changing the design to 5 lanes made improvement more important and improved player decision making. And if I continued development, I would add sound effects, particles, and multiple obstacle types with different rewards. Now, my architecture remained pretty similar to the GDD, although systems that were implemented as functions within one file instead of separate classes like I planned. And overall, the final scope really closely matched the original scope estimate and successfully implemented the core design goal. And that's my presentation.